That's the next week.
Yes. Okay, boys and girls, I'm going to be doing lesson 25, fractions as tenths and hundredths. So you're going to be seeing a correlation a lot of the time between, so tenths, that's 10, but it's a decimal. Okay, so tenths as in if it were a fraction. And then hundredths, that's a fraction as well. Okay, so to get from tenths to hundredths, what am I multiplying by? 10 times what will get me 100? So I'm either multiplying by 10, or if I'm going from hundredths to tenths, how do I get from 100 to 10? What am I dividing by? And that's 10. So I wanted to go over some vocabulary with you guys that you're going to be seeing. So hundredths. Let me give you guys a definition because you're going to be seeing that word a lot. So hundredths are the parts formed when a whole hi, love bug. When a whole is divided into 100, equal parts. So I don't want you guys to see the word hundredths and think it's the same as the number 100. Hundredths, this DTHS, that means it's a fraction, okay? Or it's a decimal. But right now we're focusing on them as fractions. And then for tenths, it's the same thing. It's just parts formed when a whole is divided into, now instead of 100 equal parts, it's going to be 10 equal parts. So tenths is not the same thing as 10. It's a fraction, so there's 10 equal parts. Okay, denominator and numerator, we should know. Denominator is that bottom number of a fraction. And it tells us how many parts there are total in that whole. So it means how many parts. So if I have a denominator of 8, that means I have 8 equal parts in that whole. And then a numerator, that's our top number. Of a fraction. And it tells me how many of those parts. So like I said, if there were 8 in our denominator, 8 equal parts, if my numerator was 2, that means how many of those 8 parts are shaded or taken away of those parts. So if I have 2 8ths, that means 2 are shaded, or maybe 2 are taken away. It's just however many it's being affected by those total parts in the whole. Okay, equivalent fractions, we should know that as well. That just means 2 or more. Different fractions. So they're different fractions, but they name the same part. That name the same part of a whole. So, 2 different fractions. I have 3/6 and I have 6/12. Different fractions, but they're equivalent because half of 6 is 3 and half of 12 is 6. And I could prove that by going, okay, whatever I do to the top, I have to do the bottom. So how do I get from 3 to 6? 3 times 2, that's 6. Whatever I do to the top, I'm going to do to the bottom. So 6 times 2 will get me that 12. So I know that they are equivalent fractions. And then a fraction is just a number that names the equal parts of a whole. So a fraction to 12. 12 of those equal parts of 12 equal parts. Okay, so that's our vocabulary. Let's get into some of these practice problems. Page 519 of lesson 25. Doss rides his bike home. He has 7/10 of a mile left to ride. Write an equivalent fraction to show how far Dos has left to write in hundredths of a mile. So they're giving me 7/10, and I need to convert it to hundredths. So how do I get from 10 to 100? I'm going from a smaller number to a bigger number, so I need to multiply. 10 times 10 will give me 100. Whatever I do to the bottom, I'm going to do to the top. 7 times 10 is 70. So how much does he have left? 70 hundredths of a mile. Okay, another one that I circled to do with you guys was on page 520, number 2. It says every fraction with a denominator of 10 can also be written as a fraction with a denominator of 100. So that's just what we did with the 7/10 on this page. The model at the right is divided into 10 equal parts, or tenths. How many parts are shaded? So let's count total. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So of those 10 parts in this whole, how many are shaded? 1, 2, 3, 4, 5, 6, 7. 7/10. If you split each tenth, so our lines went this way just to make tenths. Now I want to make 100. You can divide it into 100 equal parts. So I'm going this way 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. So if I were to count, which I'm not, if I were to count each of these little tiny boxes, I would have 100. Okay? And if I count, I know that this is 10 boxes. So 10, 20, 30, 40, 50, 60, 70. Okay? How many hundredths part are shaded? 70 hundredths. And then it says, complete the equation to show a fraction with a denominator of 100 that is equivalent to 7/10. So this is exactly what we did with the other problem. It's just really spread out for you guys. So 7/10 times what to get to 100? So I'm going to multiply my top and bottom by 10, and that'll give me my 70ths. You can also think of it as a way of money. So I know a dime. What's a dime worth? 10 cents. So it's not $10, it's 10 cents. Okay? There's 10 cents there. And then it's 10. How many cents are in a dollar? 100. A dime is only 10, so 10 hundredths is a dime. Okay, 1 dime is 1/10 of a dollar. So 1/10 is equal or the same as 10 100ths. Okay, another one I wanted to do was number 3 on page 522. Here's number 3. Akiko jogs to the park. I hope you guys are jogging. I've been picking up running, and it's hard, but I think it's worth it. It's a good form of exercise. So if you guys are running, I want to know about it, so we can kind of, log our running together maybe. She has 6/10 of a mile left to jog. Write an equivalent fraction to show how far Akiko has left to jog in hundredths of a mile. So I need to get to hundredths. I'm going from a smaller number to a bigger number. So 10 times what will get me 100? And that would be 10. And whatever I do to the bottom, I have to do to the top. 6 times 10 would give me 60. So she has 60 hundredths of a mile left to run. Okay? Another one we could do, let's see. Ooh, number 9 is a good one. You're going to see one like this on your quiz for lesson 25. Tucker is weeding his garden. The shaded model at the right represents the fraction of the garden that Tucker has already weeded. Tucker plans to weed 5/10 more of the garden before lunch. What fraction of the garden will Tucker have weeded before lunch? So already weeded. So I know that each of these rows is 10. So I have 10, 20, 30, 31, 32, 33. So 33 out of 100 he is already weeded. Oops, 100. Tucker plans to weed 5/10 more of the garden before. So he's going to do 5/10 more. But I can't add hundredths and tenths. Okay? So I need to convert 5/10 to hundredths. So if I need to go from tenths to hundredths, I need to multiply by 10, my top and my bottom. 5 times 10 would give me 50. So now I can add 33 hundredths plus 50 hundredths. And 33 plus 50 would give me, Mrs. Mayberry just called you, 83, and then my denominator stays the same. 83 hundredths. What fraction of the garden will Tuckle have we did before lunch? Which one says 83? B. And there's your correct answer. So I hope this helps. Remember, you can always email me or Miss Brunoli if you have a specific question. We can even arrange a Zoom call. Doesn't matter, just let us know and we are here to help.